Shake well before serving. A small but such an important label. It's so small some may not even notice it. But why do I need a shake? And what happens if I forget to shake? Most plant milk is made by grinding the plant source with water. For example here, almond milk is made with almonds and water. When the plant is ground, the proteins and the oils of the plant are now in suspension within the liquid. The complexity of these particles make it difficult for them to stay suspended within the liquid. Most plant milks are filtered to remove any skins. And as you can see here, even plant particles have begun to settle down to the bottom. Therefore, when drinking a plant-based milk, it is advised to shake before so you get an even distribution of particles and an even flavor profile. Separation in beverages reduces quality and is an inconvenience to consumers. Various processing methods have been developed to improve the stability of plant milks. The newest technology being ultra-high pressure homogenization, UHPH for short. UHPH is similar to conventional homogenization, except that much higher pressures are used, at the ranges of 450 megapascals. Raw milk contains different sized particles. After an hour, these smaller particles start to gravitate towards the larger particles. In dairy milk, this is known as creaming, where the fat globules rise to the top. In plant milk, the particles settle down to the bottom of the container. Homogenization is a distribution of equal-sized particles that are suspended throughout the liquid. Homogenization is achieved using a homogenizer. The homogenizer forces the beverage through this feed at pressures around 20 to 40 MPa. The beverage is then forced through these small holes, creating much smaller particles. At higher pressures, the liquid passes through the gaps at much faster rates, causing a higher shear force to form smaller particles. Based on Stokes' law, the rate of sedimentation in a fluid is a function of the size of the particles, the thickness of the fluid, and the velocity of the particles. And as the size of the particles reduces, the sedimentation rate also reduces, causing the particles to settle to the bottom at much slower rates. Ultra-high pressure also causes the temperature of the beverage to increase to temperatures that kill off bacteria. The increase in temperature during pressurization in a homogenizer is due to no heat loss and the increase of potential and kinetic energy experienced by the beverage when passing through the gaps. Therefore, UHPH can improve both the stability and the safety of the milks. Current methods like ultra-high temperature pasteurization coupled with homogenization is a two-step process that uses indirect heating to heat up the beverages to sterilization temperatures, about 121 degrees Celsius, which kills off all bacteria. Then it passes through a homogenizer, which stabilizes the particles. And then finally, it is hot filled into aseptic containers. UHPH will allow for a single hybrid one-step process where beverage will only have to pass through one machine and will be able to perform both functions. It will increase the shelf life and the safety. Soon you'll be able to drink your plant milk without shaking it, and a small label will not be necessary.